Okay, good afternoon all of you. Suppose you have three equations with you. These are the three equations: x plus y plus z equal to 1, then 2x plus y minus z equal to 2, and then 3x plus 2y equal to 3. So suppose you have these three equations. So suppose you have these three equations: x plus y plus z equal to 1, then 2x plus y minus z equal to 2, and 3x plus 2y equal to 3. Suppose you have these three equations and you are asked to solve for x, y, z. Now, if you see carefully, the first equation and second equation, the total of the first two equations is equal to the third equation, right? If you watch carefully, this equation plus this equation is equal to the third equation. That means that if you add the first two equations, you will get the third equation. So that means the third equation is redundant. Because if you add the first and the second, you will get the third. So that means the third equation is redundant. Now, whenever you have a situation like this, you have three equations out of which one is redundant. So we say that the three equations are logically consistent, but in effect there are only two because the third one is redundant. So we say that the equations they are logically consistent with infinite solutions. So if you want to know how many solutions these three equations have, so they will have infinite solutions. Like there is nothing inconsistent about them, they are logically consistent with each other, but they will have infinite solutions because one of them is redundant. Now, if you remember the last day we had discussed that whenever you have a matrix equation like this, A into x equal to b, then the solution of this will be x equal to A inverse into b. So this is the equation A into x equal to b. The solution of this will be x equal to A inverse into b. That means 1 by determinant A into adjoint A into b. So the solution of this equation x will be 1 by determinant A into adjoint A into b. Now we can say like this: case 1, if determinant A is 0 and adjoint A into b is equal to null matrix, then you will have infinite solutions, and the three equations, they will be logically consistent. Okay? Once again, suppose if the determinant is 0 and adjoint A into b is equal to null matrix, then the equations will be consistent but they will have infinite solutions. So this is one example of infinite solutions. The second possibility is that determinant A is 0 but adjoint A into b is not null. In that case, the equations will be inconsistent with no solution. Alright, suppose if determinant A is 0 but adjoint A into b is not equal to null, then the equations will be inconsistent and they will have no solution. You will not be able to get any solution out of them. For example, if I have x plus y plus z equal to 1 2x plus y minus z equal to 2 and 3x plus 2y equal to 4. So if I have x plus y plus z equal to 1, 2x plus y minus z equal to 2 and 3x plus 2y equal to 4. So if I have three equations like this, then these three equations, they will be inconsistent because the third equation is violating the first two. Whatever result you are getting from the first two, the third equation is violating that. So these three equations will be inconsistent and they will not have any solution because the third equation is violating the first and the second one. So that is case 2. And case 3, if determinant A is not 0, then the equations will be consistent with unique solution. So this is case 3. So what is case 3? Suppose if determinant A is not 0, then the three equations will be consistent and they will have a unique solution. So these are the total three cases, and case 3 of course we have already done classwork and I gave homework also based on case 3. So we have already had a look at case 3 and today now you know about case 1 and case 2. So that is the topic for today. It is called rules of consistency. That means if you have three equations, then whether they are consistent or not, and if they are consistent, do they have infinite solutions or do they have only one unique solution. So that is the topic for today. And now based on this I will give you the usual homework. So the first homework question is, show that 3x minus y minus 2z equal to 2, 2y minus z equal to minus 1, 3x minus 5y equal to 3. Okay, show that 3x minus y minus 2z equal to 2, 2y minus z equal to minus 1 and 3x minus 5y equal to 3. Show that these three equations are inconsistent. That is the first question. Okay, next question is you have to solve these equations. X plus 3y plus z equal to 6, 3x minus 2y minus 8z equal to 7, 4x plus 5y minus 3z equal to 17. Okay, this is the next homework question. Solve the equations. X plus 3y plus z equal to 6, 3x minus 2y minus 8z is 17, 4x plus 5y minus 3z 3x minus 2y minus 8z is 7 and 4x plus 5y minus 3z is 17. Okay, this homework question you have to prove that these three equations are inconsistent. That means you just have to prove that determinant A is 0 and adjoint A into B is not equal to null. That's what you have to do. And the second homework question, number 2, you just check while you are solving it, you just check that if determinant is 0 and adjoint A into B is null, that means it is consistent with infinite solution. Okay, sorry for that interruption, all of you. Sorry for that interruption. Actually, in question number 2, if you find that the determinant is 0, but adjoint A into B is also 0, that means that in question number 2, the three equations will be consistent with infinite solutions. That means one of the three equations will be redundant. And if you find that happening, then you ignore any one out of the three equations and solve the other two. Like suppose you have three variables x, y, z, so solve x and y in terms of z, like that. Solve any two variables in terms of the other. So that is your homework, question 1, question 2, 2 questions homework, and you can submit the homework by 9 p.m. tomorrow, that is Wednesday. That will be all by all of you.